on number 1 under the binomial theorem, you're supposed to expand x cubed minus 2y to the fourth using the pattern of Pascal's triangle, the binomial coefficients and exponents. So first of all, I wrote the row of Pascal's triangle that I need for this problem. So the coefficients would be 1, 4, 6, 4, 1. My patterns of variables would start with, if this were a plus b to the fourth, an a squared, and it would end with a b, or an a to the fourth and end with a b to the fourth. The a's would count down, a cubed, a squared, a, and then no a at all. The b's would count up, no b, b to the first, b to the second, b to the third, b to the fourth. Then the coefficients in front of them are the 1, 4, 6, 4, 1. Now I know this isn't a and b, but it's good to write that pattern first so that I know what to do with the x cubed and the negative 2y. So a is x cubed and b is negative 2y. So now I'm going to just take this template here that I've created and substitute x cubed every place there's an a and negative 2y every place there's a b, being careful to use parentheses because of the exponents. So here I have x cubed to the fourth, 4 times x cubed cubed times negative 2y to the first. You don't have to have the first there. 6 times x cubed squared times negative 2y squared, plus 4 times x cubed times negative 2y to the third, plus negative 2y to the fourth. Then I just need to simplify and combine my terms using proper order of operations. So first of all, applying the exponent to everything that's in the parentheses, then multiplying it together. So this one's pretty easy, it's just x to the 12th. Here it's 4 times x to the third times negative 2y. Now I don't want to leave it like that. I want to multiply the 4 times the negative 2 and get negative 8 x to the ninth y, x to the ninth y. Then I have 6 times x to the 6th times positive 4y squared, or 24x to the 6y squared. The third term, 4 times x cubed times negative 8y to the third, or negative 32x cubed y to the third. And then this would be positive 16y to the fourth. Next question, it asks you to evaluate 8, select 5 using factorials and show your work. I would want all of this work shown. You will not have a calculator available for this problem, so you're going to have to be able to do this without a calculator. You need to know that 8 select 5 is 8 factorial over 3 factorial, 5 factorial. You need to be able to expand the factorials in order to cancel, to reduce the fraction, to cancel out like terms in the numerator and denominator. Sorry, I should say common factors in the numerator and denominator that reduce to 1. And so this ends up being 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 is the same thing as the 5 times 4 times 3 times 2 times 1 in the denominator, so I can just write 5 factorial when I get to this point and reduce that with the 5 factorial below it. The 6 divides by the 3 times 2, and then what's left over is 8 times 7 is 56. In this third one, we're going to use the binomial formula to find the 7th term of 3x plus y to the 10th. Here's my binomial formula. A is 3x, b is y, and n is 10. So I'm going to substitute those three things into the binomial formula. So I have r going from 0 to 10, of 10 select r, 3x to the 10 minus r, y to the r. The r is still there because the r is the number that changes depending on which term I'm wanting. If I wanted to write out all 11 terms, I would start by substituting r equals 0, r equals 1, r equals 2, all the way up to r equals 10, and I would get all 11 terms of the sequence. But I just want the 7th term. Excuse me. Since the first term starts when r is 0, the second term when r is 1, etc., the 7th term is actually when r is 6, not when r is 7. So I'm going to write 10 select 6, 3x to the 10 minus 6, y to the 6th. So 10 select 6, 3x to the 4th, y to the 6th. 10 select 6 is evaluated as 10 factorial times 4 factorial, or 10 factorial divided by 4 factorial times 6 factorial. 3x to the fourth would be 81x to the fourth, y to the sixth. So I just need to figure out what number this is. So I wrote 10 times 9 times 8 times 7 times 6 factorial, which divides out with the 6 factorial in the denominator. Then 4 times 3 times 2 times 1. The 4 times 2 is 8, so I can divide that out with the 8 in the numerator. 3 goes into 9 3 times, so the numerator reduces to 10 times 3 times 7. 30 times 7 is 210. 210 times 81 is 1,710, or 17,010, x to the fourth, y to the sixth. The other alternative to this would be to use Pascal's triangle to get this huge number, which I really don't want to have to do. On your calculator, you could also type in NCR and in parentheses 10, 6. However, if it's a small enough number, I want you to be able to do this by hand. So make sure that you can do it either way.